So in this video today, we're talking about writing inverse functions and then deciding whether if two functions are in fact inverses. Okay, so we're going to do a little practice with some algebra to begin with, and that is, of course, by first finding the inverse of our function g. Okay, so remember this notation with this g raised to the minus 1 business is read as g inverse or g of x inverse. The inverse graph, the inverse equation from your original letter g function. Okay, so our steps, right? We have some steps. Every time we're trying to write an inverse, the first step is always to switch your x and y variables. That's the first step anytime we're trying to write an inverse equation. Right? So in our problem, g of x, right, this is the y value, and this is your x spot. So we're going to switch those two letters to begin with. Switch them. So I have an x on this side. X equals 3 times y minus 4 all divided by 2. X equals 3 times y divided minus 4 all divided by 2. So now we have to our job is to once again solve this equation for y. So our first step in solving for y is going to be to multiply by that denominator. We want to get rid of that denominator. So you multiply both sides by 2. And that gives you a 2x on the left side, and we still have a 3y minus 4 left on the right side. And so I hope you're okay with keeping y on the right side, because our next step is going to be to add 4. If we're trying to isolate or get everything away from the y value, we do the easy or the elementary steps first. Get rid of our denominators, add or subtract, and our last step is to divide by 3. So once again, there's lots of ways that we can write this division by 3. But since our original problem had it written like that, I think we're just going to write it like that also. And your last step is to not leave it as y, but write it as y inverse. So the inverse equation to our original function is 2x plus 4 divided by 3. So now let's look at the pre-calculus going on here. It says find g of g inverse. Find g inverse of g. That means we're going to take your g inverse equation that we just created, right? We just made an equation to represent g inverse, and we're going to put that equation into your x value in g. Okay, remember, this is called a composition. We are composing two functions. Okay, we are replacing x with an equation. Okay, so we have 3 times. Oh my goodness, what was g inverse? Let's go down here and see. 2x plus 4 over 3. Okay, so that's what the g equation or g inverse was, right? I guess y g inverse, that's what it was. A little specific. And then I still have my minus 4, and I have all of this divided by 2. So I am taking my inverse equation, which was y inverse down there from a second ago, and I am replacing x with it. Now, what can we do to simplify this? Do you want to distribute? Do you want to divide by 1 and make this into a fraction? What do you want to do? Right? Because there's lots of things we can do. But in the end, what ends up happening to that 3? It ends up dividing this 3. Because what is 3 divided by 3? That's 1. So when essentially the 3 on the outside and the 3 inside of that fraction cancel each other out. Okay, they divide each other out. So 2x plus 4 is left in my numerator still, and then I have a minus 4 all divided by 2. Okay, our next step is going to be combining like terms. What is 4 minus 4? Hopefully you know that's 0. So I just have my 2x left, and 2x divided by 2 is x. So when I compose the inverse with my original function and do the simplifying, my final answer is just the variable x. And pretty interesting stuff. Well, let's see about this one. This one says take your g function, the original g function, and plug it into your inverse equation. So let's see, what was our inverse equation again? That was 2x plus 4 divided by 3. So I have 2 times something plus 4 all divided by 3. Okay, I am doing a composition. 2 times, now this is my equation that I am substituting, 3x minus 4 all over 2. So there is my composition. 2 times 3x minus 4 over 2 plus 4 all divided by 3. Okay, and your simplifying steps are pretty much the same. Right? The 2 on the outside divides by the 2 on the inside. Okay, so those divide each other out and give you a 1 plus 4 all divided by 3. Okay, then we have your combining like terms of minus 4 plus 4, which is 0. So then we have 3x divided by 3. 3x divided by 3 is simply reduces to x. Okay, now of course I hadn't told you this before, but that's exactly what we should be expecting the answers are going to be. Okay, that's exactly what we are expecting the answers to be, because g and g inverse are the inverses of each other. And when you compose inverses, the answer is x. So here is our pre-calculus theorem, basically. If two functions f and g are inverses of each other, then two composite functions will equal the same thing. Okay, so if we take your g and you plug it into f, it should always simplify down to just x. Okay. Similarly, if we were to take the f and plug it into the g this way, it would also simplify down to just giving you an x as your answer. Okay. That's how we know that two functions are inverses of each other. If, when you compose them, they simplify to just the variable x, that means those two original functions are inverses of each other. So let's see, our next thing says, determine if these are in fact inverses or not. Okay, so what it's asking us to do is our compositions. So let's do the first one. Let's do f of g of x. So we can see, right, if we divide, 2 divided by 2 is 1. That leaves us with an x minus 3 plus 3, of course. And then here, once again, these give you a 0, and your function reduces to just x. Guess we should do that in red. Just x. So the first composition gives us exactly what we were thinking it's going to give us. Okay, so now we have to check the other way. What about g of f? Because one way might work and the other way might not. I know it sounds crazy that it happens that way, but sometimes it does. Especially if your algebra kind of gets a little sticky and your brain doesn't exactly function correctly. So here we are replacing in the g equation, x minus 3 over 2, we're replacing x with 2x plus 3. Okay, so let's see what happens. We can combine our like terms. Right, there's your 0. So 2x divided by 2 right? 2 divided by 2 is 1, and we just have x left over. So because it works both ways, that means that, yes, those two functions are inverses of each other. Okay, both compositions gave you x as their answer, which means that they are inverses of each other. Okay, that's the analysis that we do once we perform all the algebra. Okay, so here are two more. Let's see if these two are inverses of each other. So there's our first composition, f of g of x. We're replacing x with 2x plus 1. Okay, so I want you to notice something here. This is a fraction, and this is a number. Okay, in order to subtract a number from a fraction, I have to change my number into a fraction, right? Because only fractions can subtract fractions. And in order to do that, my denominators have to be the same. So I'm going to change my 1 into a fancy 1. And that fancy 1 is going to look like 2 divided by 2. Because what is 2 divided by 2? Well, that's just 1. So I have not mathematically changed my equation at all, but I have now created something that I can actually add and subtract, a fraction minus a fraction. Okay, so I have 2x plus 1 minus 2 all divided by 2. Okay, so I've combined these two numerators, right, under one denominator. You never add or subtract in the denominator. You're only doing that in the numerator. What is 1 minus 2? And that's 2x minus 1, all divided by 2. Is there anything else I can do here? I mean, I know that you kind of want to do this, but you can't unless you do it to both of the terms. Okay, because it's both of these terms divided by that. So 2 divided by 2, sure, that's x, but I have this 1/2 business still, right? 1 doesn't divide by 2. It doesn't cancel. So the simplest I can write this is x minus 1/2. So what should my analysis be about these two functions? Are they inverses? The answer is no. When I did my substitution and simplification, it did not simplify to something with just an x. It still has an x minus 1/2 business. Okay, but just to be thorough, let's go and try the other way also. So you see, when we do the other composition also, we do not get just x as the remainder, or as the simplifying thing, which means that these are not inverses of each other. Okay, so not all of these things are going to come out to be pretty. Okay, so these are in fact not inverses of each other. So that's how we do, that's our test. If two functions are inverses, then when you compose them, your answer is just x. And if it's anything other than just x and you did the algebra right, that means those functions are not inverses of each other.